So I don't like to Google things without checking. So I just thought I would, since we're talking about the radicals in class, I decided to Google radical 80s, and this is what came up under images here. Some very radical. That says rad, not bad. Rad. So the 80s. I'm a child of the 70s. I was born in the 70s, but I grew up in the 80s, and these things are very emotional. Right now, I'm watching these. And I'm very emotional looking at them. Clothes like everyone dressed like this. This is a typical family. Mother, father, maybe even grandmother and granddaughter here. Over here we have Gary Coleman and David Hasselhoff, two very radical people from the 80s. That car could actually speak. That was Kit from Knight Rider. We and the way we would travel most of the time in the 80s was on a skateboard, as you can obviously see. Okay, so that's going to motivate you, I think, and motivate me right now. I was a little tired, but now I have complete motivation to continue with my teachings of Unit 1B, Day 2, more radicals, even more rad. We could call it this if we want to, or radicaler. Oh, that's a word. Okay, so now what we're going to do is rationalize denominators. So what we have are fractions, things like this. 3 root 7, and we don't like this. Okay, we don't like to have a radical on the bottom. We want to have a whole number on the bottom. That is because when we look at fractions, fractions are nice to deal with when you know what you're looking at here. So for example, if I have quarters, right, and I'm looking at quarters, I kind of know what a quarter is all about, right? Now if I have thirds, I kind of know what a third is about. 2/3 is, 60, 70, 67 or close to 70% of a pizza. Even if I had something like 17/3, I can figure out kind of what that's all about, right? There's 350, 3 times 5 is 15, so 5 and 2/3, that sort of thing. But if I said to you, hey, what about the root of 19? If I have 8 root 19s, that's not something we're really into. And same with this, right? So if I go over here and say there's 3 root 7, that there, I'd like to clean that up a bit. And to clean it up, what we do is something called rationalizing the denominator. And what you do is you multiply this fraction, the fraction that you're dealing with the root or the radical, sorry, that's in the denominator. So what you do is you have 3 root 7. You just multiply. You want to multiply the bottom by root 7 to get rid of this radical sign. And when you do that, you can do that, but you have to multiply the top by the same. So root 7 over root 7, that's like anything over itself. That's 1. So I'm taking this and multiplying by 1, and I can do that, and that doesn't change anything. So when I do this, remember my rules of multiplication with radicals. 3 times whatever's in front, there's a 1 here, and you multiply what's in front of the root signs together and what's under the root signs together. This is now, we're not going to mess around with this. We know this is root 49, but we also know that that's just plain old 7. Okay, so that's called rationalizing the denominator. If you have something like this, 2 over 3 root, 11, you could multiply the top and the bottom by 3 root 11 if you want to, but it's more work. So what we just do here is we multiply just by root 11. Okay, so you could put a 3 there and a 3 there also, but then you're going to end up canceling at the end anyway. So the top is 2 root 11, and this will be 3 times 11. Okay, so let's work this out real quick. This is really a 1 in front here, right? So 3 times 1 is 3. Root 11 times root 11 is root 121. Root 121 is 11. So we can just go straight into this, and that leaves us 2 root 11, and 3 times 11 is 33. So I have that. Okay. If you have the only other really complicated type of question, or not even really complicated, is when you have something like this on the bottom. If you have 3 root 5 plus, I don't know, root 6 on the bottom, and on the top, I'll keep this simple, I'll just put 1. Now this here, we can't multiply by this, but what we do is we're going to multiply by something called, which we've used in the past already, called the difference of squares. And you're going to see what's going to happen is if we use difference of squares, remember this, a plus b, a minus b, when you FOIL this out, you get a squared plus ab minus b squared, and that cleans up to a squared minus b squared. Okay, so that is that. Or we did it the other way around where you have this, remember, you have something like this, x squared minus 100, and you said, oh yeah, that's the factors are x plus 10. We look for 2 terms with a negative between them, and 2 perfect squares, that's a perfect square, that's a perfect square, and that turns into this. Well, now we're going to use this power backwards. We're going to multiply these together to get something a little cleaner on this side. And what you do is you just multiply by the top and the bottom by the same numbers, so the same things here, but you're going to throw in a negative. Okay, so that's a plus. If that was that's a plus, so now you make this a minus. So the top and the bottom are still the same. And when you do this, you're going to get 3 root 5 minus root 6. So that's 1 times this, 1 times that. And then on the bottom, what you're going to end up having, and we're not going to FOIL this out, what you're going to end up having here is just like this. When you have a plus b times a minus b, you end up with a squared minus b squared. So we're going to square the first term and square the second term. So the first term squared is 3, so that's 3 root 5 times 3 root 5. That's going to give me 9 root 45, and that's not right, right? 9 root 25, okay? And we're gonna just do it the long way first, and then we'll shorten it up. And then here we're gonna have subtract root 36. But let's think about what we're doing here, okay? So the top's still the same. Let's just do this a little easier. 3 root 5 times 3 root 5. 3 times 3 is 9, gotcha. Root 5 times root 5 is 5, so now I have 9 times 5, and that's 45, okay? And then root 6 times root 6 is 36, so I'm left with this. Okay, and then I can clean it up. 45 subtract 36 is what, 9? So 3 root 5 minus root 6. And if there's any cleaning up to do here, if I could simplify the top, then I would do so. But I can't in this case. Okay, so that's that type of question. And then that's about it. Okay, that's called rationalizing the denominator. The only thing that's going to get more complicated is when you end up at a point where you could simplify stuff. So if that happens, then you just simplify after the fact. But let's do one more rationalized denominator where the top is not just a simple number, but let's go with something like this. So if I have 3 root, this is from your textbook, or from your note, sorry. 4 root 3, I think I made the same mistake on the last video. Okay, so I look at this here, and I'm going to multiply the top and the bottom by the same thing, and it's the same numbers that I see on the bottom, or the denominator on the left. And I have to do the top and the bottom. Please don't do this. A lot of people want to multiply, make my numerator this or negative that. You can't do that. You have to be the same thing because I'm multiplying by 1. But now I'm going to use the subtract sign in between. So now I have to do all the hard work. This times this will get me 12 root 15. Okay. This times this will get me negative 15. Okay. And then under the radical sign is 10. And then that's all over. And I'm not going to FOIL this out. I know that the difference of squares will give me this squared, subtract this squared. So this squared is 16 times 3. Okay, so you square this. Remember this, 4 root 3 times 4 root 3. If I'm going to multiply that, 4 times 4 is 16. And then root 3 times root 3 is root 9, which is 3. Okay, so that's 48. On this side, I have 5 times 5 is negative 25. Root 2 times root 2 is 2, so that's negative 50. Okay, so 5 times 5 is 25. Root 2 times root 2 is 2, so that's 50. I clean that up. I will do that here. So now I'm going to clean this up a little bit here. 12 root 15. There's nothing that could simplify here. 15, there's no perfect square that goes into that. And this one, same as that, and that's all over minus 2. And you could rewrite that as the negative of that. You could take the negative and put it to the front if you want, but that's fine. Okay, if you end up having 2 terms on the front, like a binomial on the top, sorry. So back to your note, if you have this, right, over this, sometimes there's some cleaning that can be done. Okay. The day is done. I don't know if you can hear the announcements, but the day is done here. I wonder where we are right now. Very fascinating. This is in the past. Very, just like Back to the Future, another great thing from the 80s, right? Okay, so if I play around with this, now I have to do some major foiling on the top. So it'll be this term times this term. That's going to be 4 times root 2. So that's going to be 4 times 2. Okay, so root 2. Next, I have this times this. That's a 3 here. So first outsides is going to be plus 2 root 6. Insides are these 2. That's a 1. So 1 times 4 is 4. So that's going to be minus 4. That's a minus, sorry. 4 root 6. Okay, because 3 times 2 is 6. The last 2 terms here, I have 2 root 3s. So root 3 times root 3 is going to give me 3, and multiplied by 2, I get negative 2 times 3, which is negative 6. Okay, and then I'm going to clean this up in a second. On the bottom, it's the difference of squares on purpose. Oh, again, sorry, this was a negative here, right? So when there's a minus in the bottom, the denominator, when you rationalize, you're going to put the plus sign here, okay? Because we already have the minus. You're not going to put a minus here because that won't work. And then this will just be this 4 root 2 squared. So that's 16 times 2, which is 32. So 4 times 4 is 16. Root 2 times root 2 is 2. Plus, nope, not plus, minus, 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 right? So minus always, 2 times 2 is 4, times 3 is what, 12? Long day. And then I simplify on the bottom. I'll do the bottom first because it's easier. That's 20, 32 subtract 12. Then I collect like terms. There's a root 6. There's a root 6. I have 2 of them. I have minus 4 of them. I end up with minus 2 root 6s. 4 times 2 is 8. Okay, this one I didn't simplify. This one I did. I'm not sure why. But it doesn't matter. And that's this. And then I look at this, and I notice something also. You can do this. So let's say I had this, 2x plus 2 over 20. Okay, and that looks a little bit like this, doesn't it? Or minus 2. Let's just go with minus 2. I have a common factor here. I have a 2 here, a 2 here, and a 20 here, and I can common factor this. I would common factor this into minus x plus 1 over 10. And the same thing here. I can divide everything by 2 here. If it's in front of the radical, you can divide. So I get rid of this 2. So that's minus 1 root 6, which is minus root 6. That's 2 divided by 2, which is 1. And on the bottom, I have 10, and I'm all done. Okay, so that's it. A little complicated. Foil the top, difference of squares in the bottom. Okay, clean it up, collect like terms, and then common factoring. Very extensive work here, okay? And don't forget, practice this stuff, and we have some worksheets to work on. Okay, take care.